Hello, this is Scott Denstead, Weather Systems Engineer and co-founder of WeatherSpork, your best online source for aviation weather and education. In this particular video, I'm going to do a follow-up to a video that was done by Matt Guthmiller. Now, he made me aware of a flight he was taking in 2018 at the end of August. He was headed from St. Paul Downtown Airport up to the Duluth International Airport, and it was departing about 10 p.m. in the evening. Now, as you can see from this FlightAware track, it didn't go as well as he had planned. There were definitely some regions up into the Duluth area where there was some large area of thunderstorms in that region that he would have had to eventually contend with. But he wasn't expecting to find himself in any significant weather right after departure. And that's what he described to me. As he took off and he was climbing, he saw this light area of precipitation, but he also started seeing some lightning. Specifically, he was saying it was cloud-to-cloud lightning, essentially along his route. So obviously that concerned him, so he did a hard left turn to the west here and ended up diverting to Flying Cloud Airport. That was probably a good choice given the simple fact that there were a lot of unknowns, and certainly when unknowns pop up, a lot of red flags, and the simple fact he was picking up some pretty significant moderate turbulence, it was a good decision for him to terminate that particular flight. Now I'm going to talk a little bit about the weather setup here so you can kind of understand what clues, if any, there were, and try to better understand this kind of convection that was occurring in this particular region. Now Matt sent me a screenshot of his YouTube video here where it shows the multifunction display. And sure enough, you can see on the SiriusXM display here that you have a light area of precipitation, nothing in the yellow or red here, only kind of a dark green shade, which you wouldn't expect to see any thunderstorms coming out of that. But again, you can't necessarily just use the color as a depiction of the event that's going on. And you can see these plus signs are all areas of lightning strikes. Now, the thing I like about the SiriusXM satellite weather is that it shows all kinds of lightning, all forms, including cloud to ground as well as intra-cloud lightning. And he described it mostly as kind of intra-cloud lightning going on, as whereas the ADS-B lightning only shows you cloud to ground lightning. So this is really important, especially in the Midwest and especially into the central and northern plains. We see a lot of thunderstorms are dominated by intra-cloud lightning, especially on the initial development stages of these thunderstorms. So it's real important to have all the information available to you. So he also was getting kind of a nice wind out of the south and west at 41 knots. And that was when he was around 6,000 feet or so. So it's really important to grasp the big picture first to see what was going on. And so we'll walk through that and see how this weather evolved. So one of the first things I did when he threw this at me was to go ahead and look at and pull the actual NEXRAD image from the archives. And sure enough, it's very easy to see here that we have some really significant cells out here that were moving in the direction of Duluth. And this line of weather extending all the way down, so it's a linear shape, and that should give you some clues. Anytime you see a line of weather like that, it's usually organized. It's not necessarily always an indicator of convection, but most of the times it is. This was about the time he was probably going out to pre-flight and get ready to depart, just a little bit before 10 o'clock in the evening. Now here's the time frame, about the time he started to really start to see some of that lightning out there. And once again, Duluth has got its share of problems now. But in the end here, you see this very, very weak line of precipitation. Certainly not worthy of what you would expect to see any kind of lightning, but convection doesn't necessarily have to have lightning in it. In fact, I like to think of convection as the generic term. Convection tells you have vertical mixing and therefore the possibility of turbulence. In order for it to be a thunderstorm, it actually has to have lightning strikes. And there are times where, especially low-topped convection like this is, you may or may not have lightning associated with it. In this case, there was isolated areas where lightning occurred. And of course, lightning is a good signpost for convective turbulence. Now the big picture, this is valid around 3Z, so just about the time he was departing. You can see that there's not any real major weather systems here. We have a kind of a stationary front, which I think probably should have been a cold front at this time, because the winds in the upper levels were out of the west, which usually means that it'll force that front from west to east. But certainly no major forcing that's going on, any dynamic weather associated with it. And that's because the surface depiction here doesn't really tell you the full complete story about the big weather picture. We have to actually look at the upper level flow to kind of see what's going on there, because a lot of times dynamic weather that occurs where you get some significant amount of lift going on that produces convection happens also with the upper level flow as well. And you can see this is valid 3 hours later at 6Z. There was a trough that was analyzed here. This dashed line is a surface trough. Normally that shows some kind of boundary or wind shift going on. Perhaps in the previous 3 hours at 3Z here, maybe the analyst here did not necessarily see that, but at this point in time they finally picked up on that. And again, it may be kind of due to some of that convection that was moving out of the Duluth area, but certainly extended out into here. I suspect that there was some kind of boundary going on down here in the Minneapolis area that Matt happened to run into. So here's the Prague chart that would have been available to Matt before he departed. And this is valid at 0Z, so roughly 3 hours before he was planning to depart. And sure enough, this Prague chart does show that this is now a cold front, or expected cold front, that is moving to the east with time, with an area of low pressure shown up here in the northern part of North Dakota and Minnesota. And what you see here are essentially these slashed areas are regions of possible thunderstorms. And anywhere you see the dark red or dark green, you have the greatest chance. So this is a probabilistic forecast of which the light green areas and the hatched area around it could be as low as 15%, 15%, or as high as 55%, with the darker green areas and darker red areas making the possibility that you're dealing with a 55% or greater chance. So those are the areas you certainly need to pay attention to. That was kind of on the doorstep of Duluth as it's moving to the east with time. Now here's the upper level flow that I mentioned, and this is the upper level chart, and it's not really something that pilots pay a lot of attention to, and it can be kind of difficult to interpret, but essentially these lines here are not lines of constant pressure like you see on the surface charts. These are lines of constant height, and you can see a little bend in all these height lines here. And that's a weak upper level trough. Now he was moving from Minneapolis up into the Duluth area, out further to the east, but essentially that trough, that upper level trough, is bringing a little bit of upper level disturbance in and possibly causing some of the convection that was occurring in that region along his route. Now I like to look at the Storm Prediction Center at again the big picture level here. And anywhere you see a colored region, whether it's yellow, green, or light green, that's an area that the Storm Prediction Center expects to see the possibility of thunderstorms. And this is valid from 1Z to 12Z the following day, so it shows you here that there even risks a slight risk of severe thunderstorms. And severe thunderstorms are those that produce strong straight line and gusty winds, as well as the possibility of large hail, or the potential of even tornadoes in some cases. And that does show in and around that area where Matt was planning to fly, there was the potential of a slight risk or elevated risk of those severe thunderstorms. This is a pretty large range of time here from 1Z to 12Z. So I like to also look at the enhanced resolution thunderstorm outlook that you see here. Now this doesn't depict severity, but only the probabilistic approach. And you can see here that there was a 40% risk area right around that same region where he was planning to fly up to Duluth. And this is valid from 0 to 4Z, so right in that range of time that he was planning to make that flight. And we do know that there was some convection in that region, but this would have been a good forecast to look at prior to departure, and knowing that he was headed in that 40% area. And here's another product that is available in WeatherSport that provides, again, a fine resolution in terms of thunderstorm prediction. In this particular case, this is valid from 0Z to 4Z, same as what we just looked at. In fact, this is a product that the forecasters at the Storm Prediction Center uses. And again, it shows that we're dealing with a pretty significant chance here, greater than 40% chance along that entire route. So this area was primed pretty well for a convective outbreak. And if you also look at the extended convective forecast product, once again, we're dealing in this particular case with this kind of slashed area that you see in the middle here. Again, that's just about along the plan route of flight, where you're dealing with a 60 to 79% probability between 0 and 6Z. Again, this area was primed for a convective event. Again, all these kind of things you put together gives you a good indication of the possibility that this route was definitely primed for convection. And before I depart, I'd like to look at the SIGMETs, and specifically looking at the convective outlooks that are produced by the Aviation Weather Center. And this chart was created at 2Z, and anywhere you see the red polygons, those are active areas of thunderstorms, meaning it's an area that the Aviation Weather Center puts a box around and says, this is significant to aviation in terms of a thunderstorm. Now, you don't see that down here in the Minneapolis area per se, but this larger kind of orange shaded area that you see here is what's called a convective outlook, and it basically says in the next 2 to 6 hour window that there is a potential that thunderstorms could develop that reach convective SIGMET criteria. Again, a good indication, although kind of right on the edge, and once that front comes through, it generally becomes stable. Now, if we look at the next hour, again valid around 3Z, just about the time to depart, yes, there's that area of convective activity up there, but nothing in terms of any kind of convective SIGMET right down in the Minneapolis-St. Paul area, only up in and around the Duluth area, which again doesn't surprise me because this area was a very isolated region. I'm sure that the Aviation Weather Center probably saw that, but it didn't meet SIGMET criteria per se. But that doesn't mean that you can't run into thunderstorms outside of convective SIGMETs. And here's the last one about 4Z, again that area of weather in Duluth, in that region, but entirely encapsulated within that convective outlook area was Matt's route. Now you might say, well, if he ran into a lot of turbulence, why wasn't there an advisory out there for turbulence? Well, this is the G-AirMet, the graphical AirMet valid at 3Z, and you see nothing associated with turbulence in that region. And that's because these G-AirMets, as well as the legacy AirMet, do not predict convective turbulence. So what you see here is only non-convective turbulence, and that's real important to understand. You can still run into some dangerous turbulence, and usually it's on the convective side, even outside of the areas that you see depicted. So in this particular case, this is not going to help you in a convective kind of environment. And one of the other products I like to look at is what's called forecast radar or simulated reflectivity. And this is from the 19Z run of the high resolution rapid refresh model. And it kind of tries to depict what the radar depiction might look like in the future. And you can see it's depicted just like a standard radar image in terms of decibels of Z or dBZ. And it happens to be a composite reflectivity, so it's really showing the full range of altitudes. Of course, it is a forecast, so it obviously can be wrong, but even around 19Z, which is well before this flight, you can see there's the area of weather, it's kind of approaching Duluth, and even there's some hint of some cellular structure here around Minneapolis-St. Paul. And if you put this in motion, essentially you're looking at this is around 245Z, around 3Z, about the time he planned to depart, and around 315Z. And you can see that's kind of right near, pretty close to it. Now, nothing significant here, and certainly it's a pretty accurate picture of what he had. But again, when you look at this, this indicates that we know this particular area has a high risk of convection, and you can see here that that's showing a cellular structure as well, and as a result, would alert me that I need to be somewhat careful about that, because something as small as this eventually could turn out to be something as large as what's to the north. And you can see as that moves through, it still is a very cellular kind of look and feel to it. Again, nothing significant, and we know in reality nothing significant happened, but you still got an area of thunderstorms. And one of the other products I like to look at right before departure is, especially at nighttime when you're flying, is the infrared satellite image, a color-enhanced infrared satellite. And you can see the two different kind of mesoscale convective systems here, the one that's kind of affecting Duluth, which is right here in this area. So a flight up this region had to deal with this. So let's watch this loop as it progresses here. And you're going to notice some really light areas of precipitation, or at least of cloud coverage in this region. And you'll see how that comes through, and I'll explain the chart in a little bit more detail here. So this is right around 230Z, this is around 245, 3Z, 315, 330Z, finally 345Z. And what you're seeing here are 3 or 4 distinct cells. So the deeper the blues, the colder and higher the tops are. So you'd expect in this deep moist convection here, these thunderstorms up in Duluth, for there to be really deep clouds in that area. Well, not so much so with respect to the stuff that's happening down here in the Minneapolis area. Most of this is in the kind of the yellowish or green area, which is still essentially tops that are colder than 0 degrees Celsius. And we see a few of these light blue areas. So you can actually translate this to a temperature, a cloud top temperature, and even look up and see what the tops are on this based on the colorings of that particular satellite imagery. But what I'm kind of drawing from this is this distinct cellular structure that you see here. And that shows to me that you've got the possibility of building convection. And timing was perfect for Matt's flight, and that is around 3Z, things start to really flare up. Around 330Z, we start to see these individual cells. So we were in a slight area of weather that was evolving and building right at the time that Matt went through this region. So it's a key element to kind of take a look at before you launch, to look at the infrared satellite depiction, especially if you're flying at night. Now, one of the other clues that we'll look at in just a bit is looking at something like a Skew T Log diagram. I know most pilots don't ever use this, but there's a lot of good information. Now, this happens to be the radiosonde launch, or the weather balloon launch, out of Minneapolis, St. Paul. That balloon was launched around 23Z, and although the radiosonde observation here is valid at 0Z, and this shows the actual temperature of the atmosphere based on that balloon launch in Minneapolis, St. Paul. So it's pretty close to the time frame that he was departing, and certainly has some relevance in this particular case. One of the things you'll notice here is that the winds pretty rapidly increase, and they kind of peak out right here at around 5,000 feet. Winds are kind of out of the southwest around 45 knots, and that was about kind of winds he was seeing when he was at 6,000 feet. So there's a peak of wind there. And anytime you get any kind of vertical motion, some mixing in the atmosphere, and you mix that up with the prevailing winds that are significant, you certainly can get a lot of turbulence associated with that. Anytime that mixing interacts with the prevailing winds, that produces a lot of eddies in the atmosphere that you can essentially see as turbulence. That's one aspect of that. The other aspect of this, for folks that do spend some time looking at this, what you'll notice is I lifted this parcel. This is the parcel's lapse rate, essentially from the surface all the way up to a point where it saturates, and then it's essentially moist and it's saturated, and finally you see the parcel becomes much warmer than the temperature up here at 10,000–15,000 feet. So there's a point where it crosses over. We call that the level of free convection. Once that parcel of air that's lifted is able to get above that, then what you end up having is the possibility that can tap into all this instability, because we know the air parcel is warmer than the environment, and all this hatched region we call convective available potential energy, or CAPE. Now, the other aspect of this is that This green hatched area is called convective inhibition. Basically, you can see here the atmosphere itself in this red line is actually quite warmer than the parcel itself. But that doesn't mean that you need to start the lifting from this point upwards. So at some point in time, this cap can be eroded and eventually can tap into all that buoyant energy aloft. And one of the things you'll want to notice, especially if you're going to be flying at night, take a look at the cloud coverage that's going on. And we're going to see that in the area forecast discussions in just a bit that talk about AWS clouds. And AWS clouds are called altocumulus castanelis clouds, and those clouds are a good sign that you have some upper level instability going on. They tend to occur in the mid levels of the atmosphere from 10, 12, 15,000 feet. So especially if you start looking at METARs or observations and you're seeing them around 12, 13, 15,000 feet, that's a good indication that they are AWS clouds, which are good signposts for a convective possibility later on. So we'll keep this in mind as we're looking through that area forecast discussion in just a bit. But just wanted to point this out that certainly we were primed with CAPE values approaching 2400, which is pretty significant in terms of instability in the atmosphere. And this is just a quick representation of the TAF out of Minneapolis, St. Paul. And so this TAF was issued just before he departed, or around 0Z that evening. So that was 3 hours before his flight. But you'll notice here from 1Z all the way through 7Z that the forecaster felt that there were going to be showers in the vicinity. Now, I know a lot of pilots think of showers as kind of a benign event, but it's not. Actually, showers is a convective process. So anytime you see in a forecast or in an observation the mention of any kind of showers, either rain showers or showers in the vicinity, either rain showers or showers in the vicinity, that's going to tell you that you've got a potential convective event that could occur. And a lot of times forecasters put this in as a placeholder for a future convective event that they're not really sure about. And as you can see from the area forecast discussion, there was definitely some uncertainty going on here. But again, this is a placeholder for a uncertain convective event. So let's take a look at that area forecast discussion. Now, an area forecast discussion is written by essentially the short-term desk that we're going to look at today. And the short-term desk at the Weather Forecast Office out of Minneapolis also issues the terminal forecasts as well in the area. So this is a good introduction to kind of what the forecaster is thinking about the situation. Now, this was issued at 4:05 p.m., so this would be something that you could have read ahead of time. It's a forecaster-to-forecaster discussion, so it can be kind of technical at times, as you'll see here. But nevertheless, let's read through it and kind of gauge what's happening. I like to do this after I've done my full briefing. So it says it's looking more like the scenario 1 from this morning's discussion. We haven't read, but we could certainly go back and read that. Will be playing out tonight, which is a split setup with the local area between better upper forcing to the north and better low-level jet forcing to the south. This leaves us with very little forcing in between. So again, there's that uncertainty coming into play. We see this split setup with the most recent day 1 outlook from the Storm Prediction Center. If you remember that, we saw that there was some severe weather to the north in the Duluth area and maybe some south of the Minneapolis area. And it says that it started pulling back on the POPs, which is the probability of precipitation. It says this afternoon, satellite imagery shows plenty of ACUS, there's the ACUS again, moving across the area with steep mid-level lapse rates and broad warm air advection and isentropic lift. That's isentropic lift is lift along a thermal boundary. Essentially, this is telling you that you have instability aloft. And we already saw that from looking at that Skew T diagram from that radiosonde observation. To this point, none of this activity has been able to tap into that instability in place. About 3,000 joules per kilogram of most unstable CAPE, or convective available potential energy. So we saw that. There was a pretty significant area of CAPE, almost 3,000. And so again, this confirms what we're seeing is accurate. as it is riding above the instability. However, we are seeing a few drops reaching the ground from this activity, and you can't rule out one or two storms managing to form out of this ACUS. So had to spread some of the 20 pops or 20% probability of precipitation across much of the area this afternoon. So again, when we saw the Prague charts, we saw that it was in an area of somewhere between 15 and 55%, that light green area that was hatched in red. So again, that matches what we're seeing here. It says 20% or 20% probability of precipitation across much of the area this afternoon as this ACUS works through. But we aren't expecting anything widespread or well organized to develop, and that's actually what occurred here. And that's why the forecaster put in showers in the vicinity kind of as a placeholder for this kind of convective event. So here's kind of a rough looking picture of what ACUS clouds look like if you've never seen them before. Again, the bases are usually 10, 12, 15,000 feet up, and they have these kind of turrets on top of them typically. They look like you can see they're vertically developed. They may or may not occur in like a line here, as you can see, but when they do, when you see these kind of clouds, and again, that's a good indicator, especially near sunset, that you've got plenty of instability that these clouds here are tapping into. Then what you have to do is find a way of basically connecting the dots here with essentially the air here below the surface. Is if it can reach up, somehow reach up to these ACUS clouds, they can develop into something really significant, or these ACUS clouds can essentially build into deeper clouds, usually with the help of an upper level system moving through, which we saw as well. So let's read further. It says, where convection is developed just before 3 p.m. was just west of I-29 on the North Dakota and South Dakota border. The high-resolution rapid refresh did a decent job in pegging this, though the high-resolution rapid refresh was a little late in initiating it. And the simulated reflectivity of forecast radar comes from that high-resolution rapid refresh, and agree with the high-resolution rapid refresh and other of the convective allowing models that this activity will follow the H85, which is the 850 to 300 millibar thickness pattern or mean flow, east-northeast towards Duluth. I told you it was pretty technical stuff, but just grazing our northern county warning areas, so essentially just to the north of that. This activity will pose the greatest severe risk threat, with wind and hail being the main threat here, so no tornadoes per se. And it says also that showing up nicely on satellite is a strong shortwave trough coming out of Colorado. This wave will move into the Central Plains this evening, exciting a strengthening of the low-level jet this evening down by Omaha that will move across Iowa overnight. This should initiate widespread convection with torrential rainfall across Iowa into southern Wisconsin. So the main question with this low-level jet forced activity is how far north does it develop? We're seeing that from the high-resolution rapid refresh, the NNM, the ARW forecast models, that it may sneak up to I-90, which is much further south of Minneapolis. So what does this leave us in between? Well, broad warm air advection, that's essentially warm air that is coming from the southwest that we saw even on Matt's multifunction display and PFD there, with associated weak isentropic lift. There really isn't any forcing mechanism that looks to focus activity in the Minneapolis-St. Paul area unless the Iowa activity makes it to I-90, which means we get isolated to scattered storms depending on where we get enough forcing to break through that cap. And that cap is that green hatched area we saw on the Skew T diagram we called convective inhibition. In all likelihood, our QPF, or quantitative precipitation forecast, is way overdone and spread out with the widespread 3/4 to 1 inch of QPF east of STC/MKT line. Instead, we'll see a few streaks with amounts like this or even better, but it's tough to pin down where any of those streaks will end up at this point. Again, that emphasizes that there's a lot of uncertainty in this situation, which to me raises a lot of red flags. Now, there also is a aviation discussion in every one of these, which again, I read from beginning to end just to see if there's any clues in there. And these were basically issued for the 0Z TAF, so they're very applicable. And it was issued at 7:31 p.m. right after those were issued. So most of the areas indeed in the middle of a split scenario with tonight with thunderstorms. There will be some storms this evening from northeast into portions of the east central Minnesota and adjacent Wisconsin. That's what they were talking about in terms of what we saw and Matt saw, with the best forcing associated with the upper jet across northern Minnesota, and that's where the Duluth thunderstorms were occurring. Meanwhile, there may be storms later tonight from the southeast Minnesota into Wisconsin associated with the low-level jet and warm air advection. In between, just some scattered showers and maybe an isolated storm. So again, that's the emphasis here. It was very isolated and this is not a major event. So ultimately, when you start looking into some of the details here, you'll start to pick out some of the aspects, and that's good to take with you on these kind of flights or for you to make decisions. So it says for Minneapolis-St. Paul, a few light showers are possible this evening around the airfield. Again, light showers, the shower is a key word here because that's a convective process, but it is unlikely there will be any thunder tonight within 50 nautical miles. Well, unfortunately, that wasn't the case. As best forcing remains well north and south of Minneapolis-St. Paul. Having said that, with some instability and weak warm advection, one cannot completely rule out seeing a brief thunderstorm. So again, they're still in that uncertainty area, but this tells them that they still have a hint that there could be, though we are not really seeing a threat for anything organized impacting the Twin Cities. So in the end, Matt made a great decision to terminate the flight early because there were a lot of things that were uncertain to him. And when you're dealing with convection at night, it's really difficult to see what's happening ahead of you, even in areas, big cities where you have a lot of light coming off the city. It can be very difficult to see. So he made a good decision to terminate the flight because he wasn't really sure of what was causing this turbulence. The simple fact that there was lightning in the distance, he could clearly see that. That was a good decision to come back and terminate the flight for that evening. But there were plenty of clues out there that the possibility of convection couldn't be ruled out. There was not a lot of strong indicators for that, but nevertheless, we saw in this particular situation that the convection was producing some very, very light precipitation, and most pilots would not hesitate to fly under or through that kind of area precipitation. Certainly in the daytime, would have been a lot easier to kind of see the towering cumulus that were occurring there, but his timing was kind of perfect, meaning that he departed. He didn't see anything while sitting on the ground before he departed, but as he got up into the air, all of a sudden he started seeing lightning. So again, that was a good decision on his part to terminate that flight. So I hope this particular video was useful to a lot of you. It definitely described an unusual situation, and even for myself, this would have been a tough call, even with my background. But I like to take a lot of hints from the big picture, and we knew the setup was possible for convection. And please go out to visit WeatherSpork at weatherspork.com. That's WeatherSpork, S-P-O-R-K, at weatherspork.com. And we offer a 14-day trial for those that want to try the app.